Nobel Laureate Professor Moungi G.Bawendi, professor at the Massachusetts Institute of Technology, USA, and winner of the Nobel Prize in Chemistry 2023, visited the Hindustan Institute of Technology and Science, Chennai, to address the International Conference on Quantum Horizons 2025 Materials, Intelligent Technologies and Sustainable Futures. The event brought together global scientists, industry leaders, and academic experts to discuss emerging developments in quantum science and advanced technologies. Professor Bawendi, renowned for his pioneering work on quantum dots, delivered the inaugural address and interacted with students and researchers, sharing insights into quantum materials, innovation pathways, and the translation of fundamental science into real-world technologies. The conference was inaugurated in the presence of Dr. Ashok George Verghese, Professor Chancellor, HITS. The program also included a panel discussion on quantum materials and intelligent technologies, featuring Professor Agyan Vinu of the University of Newcastle, Australia, Mr. Josh Fowler, CEO of Zetwork, and Dr. Rajiv Ahuja, Director, IIT Ropar. The panel discussed how to translate laboratory research into scalable manufacturing and real-world industry applications. Additionally, the conference will host keynote sessions and expert talks by speakers from MIT, IIT Madras, IIT Ropar, IBM Quantum India, A-Star Singapore, and leading Australian universities, covering themes such as quantum computing, nanotechnology, sustainable materials, artificial intelligence, and academia-industry collaboration.
Chancellor is unable to attend. As you heard before, there was an urgent inspection by the Government of India in one of our other units, so he had to be away on that assignment. He conveys his greetings and his wishes to all of you and to the August gathering today. Respected Vice Chancellor Dr. Vikas Mishra, esteemed dignitaries on the dais, off the dais, scientists, academicians, industry leaders, and innovators. Dear faculty members, researchers, students, and delegates from India and abroad, members of the press, ladies and gentlemen, it is indeed a great day at Hindustan Group of Institutions today. Yet again, we have a very important guest and our friends from across the planet. It is with pride and profound pleasure that I address this gathering on the occasion of the International Conference on Quantum Horizons 2025. I extend my warmest greetings and a heartfelt welcome to all of you. At the outset, I would like to express our deep sense of honor in hosting the Nobel Laureate Professor Bawendi as a chief guest for this conference. Your presence amongst us is not only a celebration of scientific excellence, but also a powerful inspiration for our students and young researchers who aspire to push the boundaries of knowledge and innovation. I also welcome our distinguished keynote speakers, panelists, advisors, industry leaders, and collaborators who have joined us from across the globe. The theme of this conference, as mentioned by the Vice Chancellor, captures the defining challenges and opportunities of our times. Last night we had a very beautiful dinner for our guests from overseas, and we had a quite an inspiring discussion about where we are heading as youngsters, where you all need to be heading in. The concerns which we all talk about today, the environment. Sometimes when you're with such leaders who does so much for society, it is so important and relevant because it churns the best in you for the benefit of mankind. So I think last night was a wonderful dinner. Some of you were part of the dinner last night, and perhaps someday you will also share a chair with such experts, hopefully. From quantum computing and secure communications to advanced materials, clean energy, artificial intelligence, and sustainable manufacturing, these technologies are redefining how societies function, economies grow, and nations compete. As educators and institutional leaders, we must ask ourselves a fundamental question. How do we prepare our students and research ecosystems for a future driven by such transformative science? At our group of institutions, our answer has always been clear. By fostering excellence in education, relevance in research, and responsibility towards society. At HITS and our group of institutions, we're completing almost 4 decades at our university and almost 6 decades our group of institution. Our founder started it way back in '66. We'll be celebrating yet another milestone very soon. We have consistently evolved to meet the changing demands of science, technology, and industry. Our collaborations with KCG College of Technology for this conference reflects our belief that institutional partnerships strengthen innovation ecosystems. Together, we aim to create platforms where ideas flow freely across disciplines, institutions, and national boundaries. We view conferences like this not merely as academic events, but as strategic investments in the future. They help build global networks, attract talent, inspire innovation, and reinforce India's position in advanced science and technology. I firmly believe that India has the intellectual capacity, youthful energy, and entrepreneurial spirit to emerge as a global leader in quantum and intelligent technologies, provided we continue to invest in education, research, infrastructure, and international collaborations. I'd like to take this opportunity to acknowledge the tireless efforts of the conference chair, organizing committee conveners, coordinators, faculty members, and the volunteers across the faculty members and the students from both the institutions who are organizing the event. The dedication and teamwork have made this prestigious conference a reality. Also thank our sponsors.
Would like to also share that our Chancellor, Dr. Ashok George Verghese, though unable to join us this morning due to prior commitments, sends his warm greetings and best wishes for the success of Quantum Horizons 2025 and to everyone gathered here today. It is a rare privilege in the life of any institution to welcome someone whose work has not only shaped a field of science, but has reshaped how humanity understands the invisible world around us. Today is one such moment. I have the honor of introducing our chief guest, Nobel Laureate Dr. Moungi G.Bawendi, Professor of Chemistry at the Massachusetts Institute of Technology. Dr. Bawendi did not simply study quantum dots. He redefined them. At a time when the field was unpredictable, unstable, and scientifically daunting, he chose not to step back. Instead, through clarity, patience, and visionary thinking, he transformed quantum dots from scientific curiosities into one of the most impactful materials of our era, now used in advanced displays, medical diagnostics, bioimaging, and emerging clean energy technologies. After receiving the Nobel Prize, Dr. Bawendi shared a profound thought. Great science happens when people feel free to think, free to fail, and free to explore. That philosophy resonates deeply with the spirit we want to cultivate here at Hindustan. A culture where curiosity is encouraged, where experimentation is celebrated, and where young minds dare to challenge the status quo.
Legacy and vision of our institution. Wings penned by our revered founder chairman, Dr. KCG Verghese, a powerful narrative that captures the journey of a visionary who dared to dream. And Intelligent Highway Engineering by Dr. Elizabeth Verghese, founder Chancellor, an insightful contribution. Dr. Anand Jacob Verghese, compelling chronicle of leadership, legacy, and relentless pursuit of excellence.
Chennai and India so far, and I'm sure I'll come back. It's been great. I want to see more. My talk today is going to be the story of this material which we call quantum dots. It's a story of a journey of curiosity that turns into a technology. It's a journey that reflects often what happens in science and technology, where humans have an idea of how the world works. They want to explore the world, so we're explorers of the world around us. And from that exploration, they discover new phenomena, they discover new materials, new ideas, and they take these ideas and phenomena and build science and technology around them. So let me start from the beginning, for me at least. Let me tell you a little bit about myself, because I think that our history also shapes the way that we think of. So I was born in Paris, in France, and Purdue University, P-U-R-D-U-E. If you replace the first U in that word, it spells P-E-R-D-U-E, and if you know French, that spells perdu, which translates to lost. So it was a perfect place for me to arrive to there. So from West Lafayette, we moved back to Paris again, so we kept going back and forth. Eventually I ended up at Harvard University and went to college there. And again, Harvard University was on the east coast of the US at the time in 1978. It was still populated largely by private school students from the East Coast, largely, a little bit from the West Coast, but very few from the Midwest, and I was a little bit I was lost, and let's just say. I was so lost that when I took my first chemistry exam in late October of 1978, I promptly failed it completely. I got the lowest grade in the class. It was a 21 out of 100, and that was generous because I looked at all the questions and I was paralyzed, and I just wrote a little bit on each question, and all the partial credit, ended up to 21, but really it should have been 0. And so that was my first big failure on my way to becoming a scientist. And that's it. Science is really a series of failures, because you have some ideas, you try them out, they don't work, you overcome these challenges, and then you make things work, and then you proceed step by step like that. If you know the answer when you're doing research, then what are you doing? You already know the answer. So research is about finding new things, and when you find new things, usually you don't get it quite right at the beginning. So having to overcome that first failure was just the normal process of doing science. I learned to study, and then I didn't fail anymore. I learned to overcome that first failure. After Harvard University, I went to the University of Chicago to do my graduate work, and I loved mathematics, and I started out as a theorist. I was doing polymer theory, pen and paper theory, not computation, and it was great. I learned a lot, but during the first 3 years, those first 3 years when I was doing theory, I realized that I was missing something. I was missing the exploration of an experimentalist, of looking to see how the world works and discovering that part and understanding it. My brain wasn't wired quite enough as a theorist, and I was being an experimentalist, so I switched. I switched to do experiments, and that led me to doing work on very small molecules, ions, charged molecules that are of interest in interstellar space. It turns out that space is full of molecules, small molecules that are bombarded with cosmic rays that get charged and that react with each other.
That reflect the legacy and the vision of Dr. K.C. Verghese, a powerful narration that captures the journey of a visionary who dared to dream and worked relentlessly to make that dream a reality.
Giving lecture after Nobel Laureate lecture is always scary. He has taken you the world of quantum materials. And I don't have to repeat now what are quantum materials and their applications are. But I can present you something exciting that I learned from his 3 decades of research. He elegantly demonstrated us, all of us, that how by just simply tuning the size of the nanomaterial can unlock unique properties of this nanomaterial and lead in new technologies. And that can change the life of so many people. From display technologies to drug delivery system to even sensing technology, covering energy, environment and health. Today in my talk, I am going to show you some of the materials and how we can change the properties of the material by simply changing the nature of the elements and structure, morphology, and even porosity of this material.